Doctest is useful as part of the documentation for a function. As mentioned earlier though, when there are many tests, it starts to make the code harder to read. Python's unit test module provides another testing framework that allows us to write the test separately from the function being tested. We'll explore unit test by translating our test for getDivisors from doctest to unit test. On the left-hand side of the screen is the getDivisors function with doctest. And on the right-hand side is the unit test equivalent. First, we'll show you how these do essentially the same thing. We import either doctest or unit test, depending on the framework we want to use. In each doctest, we write code as if we were typing it in the Python shell, and we write the expected result on the next line. Doctest will automatically compare the two for us. In unit test, we write a separate method for each test. In that method, we write a call on the function, then we write the expected result. Unlike with doctest, we compare the two by calling method assertEqual. To assert something is to claim that it is true, and here we are asserting that the actual result should be equal to the expected result. So far, for each of doctest and unit test, we've imported the testing module and we've written the testing code. Next, we need to execute the tests. Doctest.testMod looks through all the doc strings in the current module and executes the test that it finds. It reports any differences between the actual results and the expected results. Unittest.main looks through all of the test case subclasses in the current module for methods that begin with test, lowercase t-e-s-t. It calls each of them and reports any unexpected results. When we run unit test inside idle, we are supposed to pass exitGetsFalse as the argument to main. Let's run the testDivisors module and look at the output. Each dot represents a successful test. You see that there were 2 tests and that they ran pretty quickly. Now, let's introduce an error. We'll start with a non-empty list, placing the value of the first parameter in the divisors list. Let's save the file and rerun the tests. This time we get a lot of feedback. Instead of dots, we see Fs. We are told the name of each method that had a failure, and also shown its docstring. We are shown the traceback, which is the series of function and method calls that led to the error. We're also shown the assertion error, including the expected and actual values. We even have details about what the problems were. At the bottom, we see that the test case subclass failed because there was at least one error. Now, let's fix that bug. We'll also put in a different bug that allows division by 0. We'll get rid of the old if statement and put in this one instead. It's time to retest. Only one of the tests divided by 0, so there's only one problem this time. Instead of an F, which is caused by an incorrect assertion, we see an E, because our second call on function getDivisors resulted in an error. Again, we see the method name and docstring and a traceback. This time, the traceback shows us that on line 18 in our test module, we called function getDivisors, and that on line 16 in function getDivisors, this line of code caused a 0 division error. As you can see, we get more detailed feedback with unit test than we do with doctest. We also have separated the testing from the code, which allows us to write a lot of tests without affecting readability of the code. Typically, we'll write one test case subclass for each function we want to test, and we'll write one test method for each function call.